All right, so I was practicing making sure it was working before, so that's why I'm that high. All right, so we are working on chapter 10. We're working on section 10.4, choosing appropriate measures. So here's our key idea, choosing appropriate measures. Somewhere in your notes, you will need to make sure you know this because this will help you throughout the entire process. The mean absolute deviation, that MAD, uses the mean in its calculation. So if you think about it, when you're finding the mean absolute deviation, the first thing you have to find is the mean. So when a data distribution is symmetric, you're going to use the mean, that's your measure of center, and the MAD. So we have, if you recall, we have measures of center, which are your mean, median, and mode. And then we have our measures of variation, which are your MAD, your mean absolute deviation, and your IQR, which is your interquartile range. Okay, so what they're saying, we learned about our shapes of distribution, and we learned about symmetric, and we learned about if things were skewed. So if they are symmetric, you are going to work with the mean, and the median, and the mean absolute deviation. Okay, but when you're working with when you're working with things that are skewed, when you have data values that are showing, your graphs are showing that they're skewed, that's when you're going to be working with median and the interquartile range. So we're going to work with, if it's skewed, you're going to find the median and the interquartile range. Okay, so those are the things that we're going to be working with. So you just need to remember that if they're symmetric, you're working with mean or mean absolute deviation, and if it's skewed, you're working with the median and the interquartile range. All right, so we're going to work with example 1. So the frequency table shows the number of states that border each state in the United States. What are the most appropriate measures to describe the center of the variation? So before we can even figure out if it's skewed or if it's symmetric, we're going to need to actually do our graph. So please make sure, if you printed this out, you're in for a nice treat. You could just use the notes that I have. If not, you do need to use your graph paper. So here we have our graph, we have our x-axis and our y-axis, and if you notice, our first interval starts with 0, so we are not leaving a space. You're going to be very careful, and it goes up to 5, so I'm going to go to 3. I know it might not look like 3, just do the best you can, just make sure it's above 2.5, that's the halfway mark. For interval 2 to 3, we're going to go to 13. So we're going to go up to 13. For interval 4 to 5, we're going to go to 21. So we're going to go up to 21. Make sure you're writing your numbers right above it. 6 to 7, we're going to go to 11. So it's around here. I have to make sure it's below 13, so remember that. Interval 8 to 9, we're going to go to 2. Okay, and that is our interval. So now when you're looking at this, we need to figure out first, is it skewed or is it symmetric? Well, it looks like it's pretty even on both sides and then building up like stairs. So we're going to say that this is symmetric. So now if you go back to your notes up here, when we said symmetric, that means that we're going to be working with the mean and the mean absolute deviation. So it makes sense because when you're dealing with symmetric, everything is in the center. Most of your data is in the center. So if you're finding the mean, that's the true value of finding your center. And the mean absolute deviation is also another way of finding the center. So like the best way to find the center. The outliers don't look like they're mattering. It's a matter of fact. So we are dealing with just the center. So we're going to do mean and MAD. Okay? So when we're doing this, you're just going to say mean and MAD are the most appropriate. Now, obviously, you can use the others, but when it's symmetric, those are the most appropriate measures of center and variation. Because remember, the measure of center is the mean, and the mean absolute deviation is the measure of variations. All right? And that's all you need to do for that one. And then there's your try it. So now we're going to do example 2. So for examples 2, we're describing a data set. The dot plot shows the average numbers of hours students in a class sleep each night. Describe the center and the variation of the data set. So the center is either mean or median, and the variation is either MAD or IQR. And it all depends on finding out if it's skewed or if it's symmetric. So when you're looking at this, it looks like it is not symmetric. Most of the data is over here. And it looks like our tail is around here. So it looks like we're going to have skewed left. So now that we know it's skewed, we know it's not the mean, and we know it's not the mean absolute deviation. Okay? So we are going to be working with the median, and we're working with interquartile range. All right? And the reason why is because it's not really centered. So we need to find the center, and the best way to do that is to find the median and the interquartile range. All right, so where am I going to show my work? Let's do it down here. Okay, so I'm going to list these in order. So you're going to have to make sure you write a little bit small. So 6, 6.5, and all I'm doing is taking it from the dots. So here's 6, so there's my 6. This is 6.5. Then I have 7, 7.5, another 7.5. When I was grading your test, I was noticing that a lot of you were only writing some of the dots once. So you have to be careful. You can't write them once. If you have 3 of them, you need to write them 3 times. Okay, so 7.5, 7.5. Then we have 8, 8, and then 8.5. There's 3 of those. 8.5, 8.5. Then we have 1, 2, 3, 4, 5 9s. 1, 2, 3, 4, 5 9s. Then 3 9.5s. 9.5, 9.5, 9.5, and then 10. 1 10. All right, so median is finding the center, and you're crossing off. If you remember, you're like crossing off the 10 and then the 6, and you're going to go until you find that middle number, and you actually end up here. This is your quartile 2, okay, which is your median. So now we just found our median. So our median is 8.5. All right, so we just found one of our answers. Now we need to find our interquartile range. So that means we need to find quartile 1 and quartile 3. So when you're 8.5, this 8.5 we cannot use because it is our median. So we have to use just the 2 8.5s, not the third one. And when you do that, you end up here, and this is your quartile 1. Again, you cannot use this 8.5, so you can only start there. And then you're ending up being here. That's your quartile 3. All right. So now I'm going to take my 9 and subtract it to 7.5, because you do quartile 3 minus quartile 1, and you get 1.5 hours. So we're going to say 1.5 hours. So your true answer is actually going to say data is centered around 8.5 hours, which is your median. And then you can say the middle half, which is your interquartile range. Remember, that's your middle half of the data, because you're taking away those outside portions because of those outliers of the data, varies by no more than 1.5 hours. Okay? So that's your example 2. And that's it for 10-4. Good job. You can start your tries.